My name is Bella, and I'm going to be presenting about linear equations. The topic of my presentation is linear equations 4. In my presentation, I'm going to be talking about what is a linear equation, what does it look like on a graph, and different types of linear equations. I have multiple examples, including a word problem, and I will be also talking about and solving for point-slope formula and using standard formula, as well as using slope-intercept formula. Alright, starting off, what is a linear equation? A linear equation is an equation between two variables that makes a straight line when graphed. As you can see, I have two visuals, and both of the visuals show a line. And a really simple and easy way to know what a linear equation looks like is that it's a line, and it literally says in the name, linear. So, looking at these visuals, the first one is the graph of y equals x plus 3. So, as you can see, straight line, it doesn't really matter what angle it's going in, it just has to be a straight line. And later in this presentation, I'm going to show why it is touching the 3 on the y-axis. So, that's the first one. And for the second one, as you can see, there are two coordinates, 0, 4 and 6, 0. And those come from the equation at the bottom right, 2x plus 3y equals 12. And later in this presentation, I will be talking about how to find the x coordinate and the y coordinates just from using an equation. And just a brief summary for it is that if you want to solve for one variable, you have to make the other variable 0. So if I wanted to find x, I would have to make y 0, because then x would be the only variable and you could solve for it and isolate it. And so that's how you would find x coordinates. But I will do a problem where we can see how that is done, but that is later in the presentation. Okay, so now talking about the standard form formula, I have it right here, ax plus by equals c, and I do have some arrows pointing to a bunch of different things so you can know what makes up the standard form of a linear equation. So, ax, a being the coefficient of x, and by meaning the coefficient of y is b, and then a and y being variables. And then c on the other side of the equal sign is the constant. A good thing to remember is that in an equation, the variables aren't always going to be x and y. Yes, they are very common, and most likely it is going to be, but it can really be any other letter. It's just x and y are just the most common. An example to think about is the slope-intercept form formula, which is y equals mx plus b. As you can see, y and x are included, so they are very common, but they're not like the rule. They're not always there. Okay, the first example. The first example is 4x plus 10 equals x minus 5. This is a very simple linear equation, but it is good to practice simple ones, because once you're doing only difficult ones, you kind of forget the basics, and it's always good to practice. So, starting off, we have 4x plus 10 equals x minus 5. A good thing to start off with is just trying to get things that are alike next to each other or simplified. So we have the x's, or like the variables, and then we have the constants. So I'm going to start off with the variables just to have x as close to being isolated as possible, so when I simplify everything else, it's fairly easy. So I'm going to do 4x minus x, and the reason I'm subtracting x is because if I were to subtract 4x from x, so meaning x minus 4x, it would give us a negative number. And some cases that's okay to have a negative number, but in this case it's not, because that's just not how to solve it correctly. So I'm going to do 4x minus x, which will give us 3x. And a common mistake is to think that when subtracting x's that the x is going to go away. It doesn't. Oh, in this case it doesn't. In other cases it can, but in this one it won't. So you have to think that there's an invisible 1 in front of the x. Not on the 4x because there's a 4 there, but on just the x, there's a 1. So you're subtracting 4 and 1 and x and x. But the x just transferred. So you're really only doing 4 minus 1, which is 3. And that's how you got 3x. So now that we have that, we have to put it all together again because we did all this math. So now that we have 3x plus 10 equals negative 5, which is shown here. Now we have 3x and there's only 1x, so that is done for now, but not forever. Now we have 10 and negative 5, and now we want to simplify the constants. But a thing to know that is that you don't want to take away the negative 5 from the right side because then that will be equal to 0, and we don't want this equation to be equal to 0. Maybe in another type of equation, but this one, no. So we're actually going to do subtract the bigger number. So we're going to do 10 minus negative 10, so we can subtract it by itself, so that just goes away. And then negative 5 minus 10, which will give us negative 15. So now that the positive 10 is out of the equation, we just have 3x equals negative 15, which is shown here. Alright, now we have our variable on one side and our constant on the other. That's where we want it, so that's perfect. But now we're not done yet because there's still a coefficient in front of the x, and we don't want that because we want to know what x is, not what 3x is. So the way to do that is just to divide. Divide 3x by 3, because the 3's will cancel out, and then what you do on one side, you want to do on the other. So we're going to divide negative 15 by 3. So doing that 3 crosses out, so just x, and then negative 15 divided by 3 will give us negative 5. Again, as seen here, and that is solved correctly, x equals negative 5. So that's the first example. I hope you found that fairly easy because it's just a bunch of subtraction and division and just knowing what to subtract. And the next example is actually a word problem. And I did want to include a word problem because word problems, yes, can not always be the most fun to solve, but it is good because it's comprehension. You understand what you're doing because you're given a real world problem and you know what to do with the math you've been given. So, in order to solve this, we have to kind of think of what is included in this word problem. So, let's think. 2 brothers bought together 10 books. One bought 4 books. How many books did the other buy? So basically it's what plus what equals what. So we have to think, okay, what is this word problem giving us? It has given us the sum because it says 2 brothers bought together 10 books. That is the total number of books that they bought together. So you can write equals 10 on your paper, and we're all good with the sum. Now it says 2 brothers. So it's what plus what, or the 2 brothers, equals 10. But they did give us information about one brother. They said 1 bought 4 books. So that means brother 1, first brother, bought 4 books, plus what his brother bought, the other one, equals 10. So we can write on our paper 4, because we know what number of books the first brother bought, plus x, and the reason we do x because we don't know what the second brother bought. So we're just going to put an x because we don't know and we want to solve for that. And then equals 10. So your equation should look like that. 4 plus x equals 10. And again, very simple problem, just a matter of subtraction. So we're going to subtract 4 because 10 is by itself on the right side. And again, we don't want that to be 0. So we're going to subtract 4 from itself. And then 10 minus 4 equals 6. So x should be equal to 6. Perfect. Okay, and I do believe we have one more example before we do the formulas, like the point slope formula, so let's tackle that one. So, example 3. We have 2 parentheses 8 plus 2x equals 6x plus 10. This has a few more steps, but again, same general idea. So, if you remember in middle school, I believe, we learned about PEMDAS. It's coming back again. It doesn't stop after middle school. The first letter is P. So P means parentheses. So we want to look at the parentheses first. And in parentheses, we have 8 plus 2x. But that doesn't really help us because we have a 2 on the outside of the parentheses, and we've got to do something with that too. So this is when we would distribute. As seen here, I do have arrows just in case you forgot what to distribute and how. So 2 is going to go to the 8, and then 2 again is going to go to the 2x because the 2 is being distributed to everything inside the parentheses, not just 1. So that should give us 16 plus 4x equals 6x plus 10. Perfect. And now we are set with this equation, and we can leave the parentheses behind because we already solved for that. So now we have 16 plus 4x equals 6x plus 10. So now we want to do, let's see, we want to get the variables all set. So when we have when we solve with the constants, once we get that answer, we can just divide if we need to, or we can have the answer already. So let's do, a good way to do this is to subtract 4, because if you subtract 6 from 4, that's going to give you a -2, and we are trying to avoid negatives. Negatives are fine, but it's just better when they're not negative. So we're going to do positive 4 minus 4x, and then 6 minus 4x, and that should give us 16 equals 2x plus 10, because when you add or subtract by the opposite, it's going to cancel out. So it should be on the next slide. Yes, so 16 equals 2x plus 10. And now the x's are simplified, and now there's just 1x. Perfect. But now we have the constants to simplify. And again, like I said already 2 times before, don't take away the constant that's by itself. You want to add or subtract from that. So we're going to subtract negative 10 from itself, and then subtract negative 10 from 16, and that should give us 6. So it should be 6 equals 2x. So 6 equals 2x, and then you want to get x by itself, so you divide by 2, do the same on the other side, and that should x equals 3. So that is the answer to that equation. Now, going on to formulas, and including slope, because linear equations are heavily involved with slopes and stuff like that. So let's move on. So now we have the point slope formula, which is y minus y1 equals m parentheses x minus x1. And the first thing we're going to solve for is m, slope, so we need to find that to do anything in this problem. So we're going to be using the formula of y2 minus y1 over x2 minus x1, and that's going to give us our slope. So using both of the coordinates above, 4 and -3, and then 3 and -6, and we're going to be subtracting it, so if it already has a negative sign, that's going to be plus, and that is going to be shown right here. So after simplifying it and turning the negatives and the negatives to positives, it's going to be -6 plus 3 over 3 minus 4, and that should give us 3. So now back to the point slope formula. M is going to be plugged in for, or 3 is going to be plugged in for m, and now you can just choose what coordinate you want to use, because it doesn't really matter, because you're trying to find the slope of 2 coordinates. So you can choose whatever, but I'm going to be choosing the first one, which is 4 and -3, and we plug it in, and it should look like this. Now that we have this, we need to simplify it, because y minus -3, that can be simplified to y plus 3, because negative and negative is a positive. And then we have 3 parentheses x minus 4. As we've seen in the previous problem, you can distribute that, so it should be y plus 3 equals 3x minus 12, as seen here. So now that we have this, we're almost done, but we still have y plus 3. We're not trying to solve for that, we're trying to get y by itself. So we're going to subtract it from itself so it goes away, and then we're going to subtract, we're going to do -12 minus 3, because you can't subtract 3 from 3x because they're not the same. So that should be y equals 3x minus -15, and that is the final answer. So this is saying that the slope is 3, and the y coordinate is -15, and I do have a link for the graph of it, as seen here, and you can see it's going to, if I can zoom in, it's going to touch at 15 right there. So that shows that